Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, so taking a look at today's homework, problem number 57, Joyce's dad packs her lunch and always packs a yogurt. Joyce knows that there are 5 yogurts in the refrigerator. 1 is raspberry, 2 are strawberry, 1 is blueberry, and 1 is vanilla. Her dad always randomly reaches in. It's like he doesn't even bother looking at the labels, he just grabs one out. So, of these different flavors, which one is the more likely one? Well, since you got 2 strawberry and you've only got one of the others, and strawberry is the most likely, right? And what are her chances of finding a vanilla yogurt? Well, since there are a total of 5 yogurts and only one of them is vanilla, then that's a 1/5 probability, which converts to 20 out of 100. So that becomes a 20% chance of pulling out a vanilla yogurt. Copy the number line below and place the following probabilities on the number line. So 1/4 goes right around here. Remember, if this is 0, the halfway point would be somewhere, let me go ahead and thin that out a little bit. The halfway point would be somewhere around here, right? So 1/4 is going to be the halfway point between 0 and 1/2, so that goes here. 25% is the same as 1/4, so they go in the exact same location. 0.8 probability, that's the same as 8/10, which is going to be closer to 1, so that's this guy right here. 5/8 is more than half. Half would be 4/8, so it's got to be the one farther to the right, but not too far to the right of the halfway point. And then the 0.01 is 1 out of 100, 1/100th. So that's going to be the one that's closest to 0. So if we are translating this into the likeliness square, this is certain, this is impossible, and this is equally likely. So with those, you would say it's more likely that you're going to get vegetables with dinner, and more likely that you're going to get a blue marble, but less likely that it would rain, or you will be the member of the team that gets supplies tomorrow. And it's highly unlikely that it'll be 85 degrees on Saturday, but there's still a chance. It's not impossible. It's just very, very improbable, very unlikely. All right, difference between theoretical probability and experimental probability. Theoretical actually derives from the mathematical formula, whereas experimental is derived from actually conducting an experiment and keeping a tally of how often something occurs. So the chance of getting a tail when flipping a coin is 1/2. That's the theoretical probability. Let me actually color code these just for fun. Because there are 2 sides to a coin and only one of those 2 sides is a tail. So this is the actual mathematical probability. If you flip a coin 8 times and get heads 6 times, your probability is 6/8, but that's from conducting the experiment. That's not the actual theoretical probability. My mom packed lunch 3 of the past 5 days, so the probability that my mom will pack my lunch is 3/5. Well, that also qualifies experimentally, because there could be some weeks where she only packs once, or other weeks where she would pack all 5 times. This is based on keeping a tally of how often she packed lunch, which makes it experimental. The chance of winning the state lottery is 1 out of 98 million. Are actually mathematical formulas that are put into place to figure out the odds or the probabilities of winning the lottery, and it's based on the number of numbers that you need to get correct. So this is mathematical, it's theoretical. Based on mathematical models, well, there's your clue right there. The chance of rain today is 60%. So that makes that theoretical. And then Lena got 3 hits in her last 7 at-bats. So her chance of getting a hit is 3/7. Okay, well, this is based on the tally of hits that she's gotten over the past few at-bats, so that's what makes it experimental. Okay, so once again, if you're keeping track and keeping a tally of how many times something happens to find a probability, then it's experimental. If you're just basing it on the mathematical models, it's theoretical. All right, finding fractions and percents. Mariana represented several percents as portions of 100 in the pictures below. Here you got 80 out of the 100 are shaded in, so that by rule is 80%, which simplifies down to 4/5. Here you've got 10, 11, 12 and a half, so that's 12.5%, which as a fraction, you don't want to write that as 12.5 over 100. You don't want to have any decimals or fractions in your numerators or denominators when simplifying fractions. So we actually had to multiply 12.5 times 10 and 100 times 10 to get this fraction, which then simplifies down to 1/8. And then here is 10 out of the 100, which is 10 hundredths, which is 1/10. All right, finding the mean and the median. Remember, when you're finding the mean, you add up all those numbers and then divide by the number of numbers. So that's where the calculator comes into play. And one thing about the calculator is it's not ideal if you can't keep track of all the numbers that are being added on. You could accidentally leave one of those out. So we've got to be very, very careful. And I recommend students do it 2 or 3 times. If you get a different answer every time, you're making mistakes. If you get the same answer 2 or 3 times in a row, there's no way you're making the exact same mistake every single time. So that's how you know that you got everything correct. So 20.3 plus 12.5 plus 7.6 plus 13.9 plus 9.2 plus 21.7 plus 7.6 plus 17.5 plus 15.6 plus 14.1, and you get 140, and there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so we divide that by 10. You could do that in your head. You get 14 for your mean. Now, this is kind of interesting that the median is exactly the same as the mean. And since the median is typically, it's always the number that's in the middle of your data, and none of these numbers is the number 14, how could our median be 14? Well, let me show you how it could be 14. Because we're going to start with the lowest numbers, which are 7.6. We've got 2 of those, right? So 7.6, 7.6. Then we've got a 9.2. The next number is 12.5. Then we've got 13.9. We've got 14.1. Then we've got 15.6. 17.5. 20.3. And 21.7. So the numbers in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, half of 10 is 5. So the 5th number in, there are actually 2 numbers. Oh, I don't like that. There are actually 2 numbers that are in the middle. So you're supposed to choose the 1 number that's in the middle. The problem is there isn't 1 number. So what we do is we take the average of those 2 numbers. So we take 13.9 and add it to 14.1. The average of those 2 is going to be 14. Sometimes your median is not one of your numbers in your set of data. If you've got an even number of numbers that you're finding the median for, you're going to have 2 numbers in the middle, and you'll have to find the mean of those 2 numbers. So in this case, our mean and our median are exactly the same. Craig is practicing his baseball pitching. He kept track of the speed of each of his throws and put it into the histogram. Okay, so histograms are kind of like bar graphs, but they have numerical data across the horizontal axis, unlike bar graphs that would have categorical data, like what's your favorite type of ice cream? You know, you can't enumerate flavors of ice cream. So you would just have each category with their separate bars and the number of students that liked each one. But with this, we're talking about numerical data, the speed of the pitches in miles per hour. So if you look at each one of these tables, it looks like, let me go ahead and do that. He threw one pitch that was in the 45 to 50 range. He threw 5 pitches in the 50 to 55 range. He threw 3 pitches here, 4 pitches there, 1 there, and 2 here. Now, the thing about histograms is if he throws a pitch 45 miles per hour, it goes into this category. If he throws a pitch that's 50 begins the new bar, so that pitch would go into here. So we always set this up. So whatever this number is that starts our next bin, if he throws it 60 miles an hour, it goes in this. If he throws it 59, it goes here. If he throws it 64, it goes here. If he throws it 65, it goes into here. Okay, so that's the rule for histograms. So, can you tell the speed of his fastest pitch? No. You know that 2 of them were between 70 and technically 74.9, not really 75. So if it was 75, it would create a new bar. But you know it's somewhere in this range. You just don't know the exact speed. Between what speed does Craig usually pitch? Okay, so once again, let me put this 1, 5, 3, 4, 1, 2. Finding the mean or the median, it's going to fall somewhere in the middle. And so you would say it's going to be somewhere in this cluster right here. Most likely, let me actually do this. What do you have? 4, 6, 7, and that's 8, 9. My guess is that it's going to be somewhere in here. That's the median pitch. Okay? And when you broaden the median out a little bit, that's where you include some on either side of it. So most of his pitches are going to fall in this range right in here. And based on the data, what's the probability that he would throw a pitch that was between 70 and 75 miles per hour? Well, that would be 2 out of a total of 16. So the probability is 1/8 probability, which would be 12.5% if we were to convert that to a percent. All right. So good job on your homework. Sorry it went a little bit longer than I like, but it wasn't too bad. All right. Good job. On to the next one.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.